Good day, everyone. This is our second to the last module. This is module 7B, and for this mathematical part, we'll be focusing on the function approximation and interpolation. Okay, this includes yung direct polynomial approximation, Lagrange interpolation, and the Newton's divided difference interpolation. Okay, so let's first start with the introduction to this topic. When we say interpolation, this is one of the oldest problems or one of the oldest uh, methods that we're using in mathematics. And of course, it's also one of the most applied. Basically, in interpolation, what we're doing is we're finding an approximate values of a function f of x or an x between different x values, x sub 1, x sub 0, x sub 1 until x sub n, at which yung values ng f of x are given. Okay, so you have f of x values or y values. Okay, and we have x values, and then we're finding the value of that function for an x that is between, okay, those values of x. Kaya nga siya interpolation inside this range of values of x. Okay, so okay. Next, as you can see here, we have 5 points, and we're interpolating or we're finding a function f of x that passes through all those points. And when you say interpolation, we find the value f of x, okay, for a value of x between these points. All right. Now, to differentiate it with the curve fitting, ginagamit natin yung interpolation when we want to find the estimate values between the given data. Okay? And lahat, yung function dapat natin dito na hinahanap should pass, okay, through all data points used in the interpolation polynomial. So, meaning we have a function that allows us to approximate the f of x such that function values between yung mga given values natin may be estimated. So, kung wala siya dun sa range ng set of values natin, then it's not interpolation. Okay? Meanwhile, for curve fitting, we're just finding or we're trying to find the relationship between the data points. So, in this case, we don't have to pass through all the original data points, diba? From our previous modules, kapag curve fitting, we're just finding the best fit curve, okay? And that does not necessarily pass through all the points. Okay, so meaning, sa curve fitting, parang yung relationship na yung tinitignan natin. So we're getting the coefficients of a function that we want to fit to our given data. And then from there, we're constructing a function na magsasabi ng value ng dependent variable depending on the value of the independent variable. Alright, so these are the differences between curve fitting and interpolation. And ang maging focus natin for this module is interpolation. Now, let's just define the meaning of function approximation. Okay, ano ba ito pagdating sa interpolation? Okay, when you say function approximation, ang ginagawa is we're approximating a given function f, okay, from among other simpler functions. Okay, and yung simpler function na yan, usually, pero hindi naman lagi, they're usually a polynomial. Okay, looking at it at a different variation, we're constructing a smooth function from a discrete set of data points. Okay, into the first row of equations, this is the first line. Okay, and dinidefine is a notation f of k, f sub k, okay, which is equivalent to f of x sub k. Okay, ito naman sa baba, yung pn of x, okay, ito na yung sinasawag nating function approximation. Okay, such that we have a polynomial function such that when you substitute yung x value na to, ang bibigyan sa yung value na f is equal to f of k. Okay, so meaning if you have f of k, so let's say f sub 0, that's the value of the function at the point x equals x sub 0. Now, when comparing it to our function approximation or p sub n of x, pn kasi usually nga polynomial, p sub n of x, meaning if you substitute x sub 0, you should also get the value equal to f of 0. So here is the definition for our function approximation. Okay, and actually there are two cases. Okay, Case 1 is if you have a set of nodes x for x sub I, where I is from 0 to n, we're finding a polynomial p sub n of x of degree less than or equal to n such that yung p sub n of x sub I natin is equal to y sub I. Meaning, sa case 1 na to, ang meron sa'yo is points, di ba? Pairs of x and y values. Kaya hindi mo alam kung ano yung exact function that represents all these data points, right? Kaya ang tawag dito sa p sub n of x na to is the interpolation polynomial. Okay? Kasi we're interpolating between points. Okay, again, if you don't have, if what you have is just a set of points and you don't know the exact function that represents all those data points, okay, ang kinukuha natin is an interpolation polynomial. Okay? For the case 2, if you have a given set of nodes x and you know that you know a continuous function that represents these points, okay, alam mo na yung function na yun, and you're just approximating that function using a polynomial p sub n of x, then what you're doing is a polynomial approximation. Okay, yung kanina given points, ang ginagawa is interpolation polynomial to pass through all those points. On the other hand, if you have a continuous function f of x and x values, tapos gusto mong i-approximate yung f of x na with a polynomial p sub n of x, then what you're doing is a polynomial approximation. Okay? So these are the 2 points. 2 cases rather for function approximation. Alright? Now, just to answer kung bakit typically polynomial yung ginagamit sa function approximation, it's because polynomials are easy to evaluate. Diba? When you substitute values of x sa isang polynomial, madali lang kasi x squared, x cubed, diba? Can easily evaluate. Next, differentiation. Madali rin i-differentiate ang polynomial. It's direct to the point and consequently, madali rin ang integration niya. Okay? However, it does not mean na hindi na pwede gamitin ibang function for function approximation. Okay? So, let's say 3x squared plus 2x minus 7 when x equals negative 3. So, madali i-evaluate. Substitute mo yung negative 3 kay x. You can easily get 14. Ito naman, example of getting the derivatives. Okay? So, ax cubed plus bx squared plus cx plus d. Daling-daling kunin yung first, second, and third derivatives. And of course, you can also easily get yung mga integrals nila. Let's just introduce lang din yung concept of uniqueness and existence. Okay? Sinasabi lang nito is, there will be a unique polynomial for interpolation or approximation if all nodes only have one pair. Okay, and there is only yung x sub x natin may isang value lang for f of x sub k. Okay, let's say let's have a node x sub I, an element of I. Okay. So si I natin between 0 and n given. So as long as yung bawat x sub I value natin iba-iba. Okay. Tapos yung x sub I maging equal lang sa x sub j, meaning yung dalawang x values natin magiging equal lang if and only if I is equal to j, meaning isa lang, unique nga. There exists a unique polynomial na p sub n, okay, with degree less than or equal to n na nasa-satisfy either this one, yung interpolation polynomial natin, or yung approximating polynomial. Okay? So that's all for our introduction to function approximation and interpolation. Sa ating next content, I'll be discussing how to apply yung direct method dito sa interpolation. Alright? Sige, for now, thank you and goodbye.